Okay, ladies and gentlemen, welcome back. We are out in the old foundry. Kind of, sort of. Well, this is about as foundry as I'm going to get in suburbia. So, back to the task at hand. You're going to try and find out exactly how much, water you've lost from the time that you made your sand to the time now, or whatever represents now for you. Okay, maybe you just tried to make a mold out of the sand and it didn't turn out worth a crap because the definition inside your mold, all the sharp edges weren't sharp anymore because they'd all turned to dust. The edges turned to dust and fell into the bottom of the mold cavity. Real good indication that, the water's all dried up, or has dried up, at least in the majority of your sand, so that the stickiness between the grains of sand and the bentonite, or the clay, whatever clay that you might have used, the stickiness isn't there anymore because the water's gone. Okay, just to remind everybody, hopefully I've got this stupid camera aimed well enough. Here's your basic general purpose sand formula. 95% silica sand, 5% clay. I use bentonite. That's probably the cheapest clay that you'll be able to find. You can even find bentonite in some types of kitty litter. Grind up the kitty litter, you got bentonite that you can add to your silica sand. Now this and this together, as you can see by the numbers, represents 100%. Once you figure out what this weight is, you take this weight, you multiply it by 5%, and that's the weight of the water that you need to add to this to make this work. Okay? Now, in the foundry, ye old foundry, we have a batch of sand here that's been sitting inside the muller / mixer for a little while, and it has lost a bit of its water. Okay, I wouldn't try. Let's see if we can. I squeeze it, and it does conform to my hand, but see how it just crumbles? It's got a shape, but that doesn't mean that it's going to be useful for a mold. So this is a prime example of the time that you're going to have to test to see how well or how much water is still in this mixture. You've got to mix this up thoroughly before you can take a representative test, a sample of this. So I've got everything I got in here. This is my sample, okay? This is my sand. Now your sand might fill half this room, okay? Your sand might be just enough to fill up that molding bench. Don't know what kind of sand you're going to have. But in this case, this is the sand I'm testing, all right? Going to put my little lid on so a bunch of stuff won't get out. And this will hit the bottom. I need my little old hammer. My old fist is not doing the job. That certainly did the job. Okay, now, because this is as loud as it is, and I'm going to let it mix for, let's say, around 10 minutes, I'm going to pause the video now and save you the ear-shattering noises that might come into play once this turns on. So we'll be back in just a minute. It's been 10 minutes. This has been mixing in 10 minutes. I would probably, if I was getting ready to make a mold though, I'd probably had gone a little bit longer. I don't know, maybe not. I thought these were lumps, but they fall apart pretty readily in my fingers. Anyways, so dump this out. Pardon the ears for a sec. See if anything is stuck inside. No, it's fairly clean. Okay, so we got to put that in a bucket. Now these buckets, you got to weigh your buckets. See, the idea is that the more you know how much that weighs and how much that representative sample will weigh, the closer you'll get pardon me, to a true answer at the state at which that sand is. Okay, and you'll know exactly how much water is and is not in there. Okay, so I already weighed this out. This is a 2.5 pound bucket weight. And we just transfer this stuff into the bucket of a known weight. See, it almost fills up the bucket. Not quite, but it almost does. So, all right. I'll be right back. Got to get all this into that bucket. That into the bucket. Now I've got a beam scale here that I got from a yard sale. Capacity is up to 350 pounds, and I've got it set. Pretty good balance right now is 0-0, and that's right in the middle. So that's going to be fairly accurate. So let's see how much this sand weighs. Does it weigh 50 pounds? Nope. Does it weigh 40 pounds? Yes, it does. 42, 44, getting close, 45, all right, sand and bucket combination is 45 pounds. So that take away 2.5 pounds, that's 42.5 pounds of sand, clay, water mixture. Okay, this, I'll make that, let's do that, because we're going to be working in decimals, not fractions. $42.5 pounds decimal, and this is going to be very important. Okay, so keep that in mind. Now what we need to do is we need to get a representative sample of that sand, right? Well, let's get this started. Right? Let's go there to scoop. We're gonna fill this thing up as neatly as we possibly can. We're hoping. This is nothing but a food scale, but the good news is that this food scale can measure in both pounds and ounces. In this case, we have 3 pounds, 12 3/8 ounces. Okay, that's a good measurement. Okay, the thing is, the sample has got to be in the same form as the mass. Otherwise, you're going to be playing heck with your math. Okay, so you got to convert 3 pounds, 12 3/8 ounces. Again, that's a pretty good precise number. You got a 3/8. 3 divided by 8 is, and plus 12 equals, okay, that's how many ounces we have there, right? I got to convert that over to pounds. Okay, so if you know your fractions at all, you want to find out what that decimal is. You divide that by what you want. This is, you know, you have 16 ounces per pound, right? So this is going to be 12.375 sixteenths of a pound. Okay, so on your computer, on your calculator, you take that number, you divide it by 16, and that's, you have 3.77 pounds of sand in that that sample. Okay, so let's make note of that. Sample 3 point. I must have hit it again somehow. All right, let's double check. Make sure. I thought it was 3.77, but I got to double check. Make sure I didn't screw up, forget something. Okay, 3 divided by 8 equals, plus 12 equals, that is what 12 3/8 ounces is in decimal form. Okay, now to find out what that is compared to pounds, you divide that number by 16, which is 16 ounces per pound. You get 0.77. We're going to round it off to 0.77 because everything else is these next numbers is below 5, so it'll give you an accurate answer anyway. 0.77. Now you'll notice that this is in decimal form as this is, so you're not going to be screwing up your math by what do you call, mixing different different sizes or different categories. I think the teacher used to say different categories. Now, this. What do we do with this? Pardon me. Well, what you need to find out now is how much of that is sand, the sand and bentonite mixture, and how much of it is water. Now you need to drive off the water. And in this case, we're going to, instead of doing it like some chemists will do and add a chemical compound that'll turn water into carbon dioxide gas, something that I thought was pretty freaking neat when I had to take my chemistry class at the Thames Valley Technical College. In this case, I'm going to do what you're likely to do, is use the oven. Okay? And what I'll do is I'll go ahead and turn off this video as I transit, so that while I'm transiting through the house, it'll save time. And then I'll get the oven all set up also. So I'll be back in a sec. Okay, here we are. Now, first thing you need to do, the setting for the oven, whether it be an industrial sized oven or a standard little oven in somebody's house, the setting is going to be between 220 and 230 degrees Fahrenheit. Okay? That is plenty hot enough to turn any moisture that's in that sand into vapor, and it won't overburden your electrical bill, because in an hour's time, which is how long I'm going to let it sit, all of that moisture that's in there, which percentage wise should be pretty small, will be driven off by the heat, turned into steam. Because remember, water turns into steam, into vapor at 212 degrees Fahrenheit. Okay? Anything above that, you'll be turning the water into steam. You could just go to 213 degrees and it would do the same job, but then it would be doing it at a slower rate. Okay, you'd have to wait a little bit longer for you to get absolutely dry sand, which is what we're after now. Okay, so I don't know if this thing's going to be in the way. So I hit on, and I hit, come on, you're supposed to, bake, yep, on, and got to set 220 to 230. Doesn't need any bigger than that. $220. That's about right for me. And start. Okay, just get yourself a good sized baking pan like this, without getting your kitchen all a mess. Just take and dump this in there. Make certain you get as much as you possibly can out of it. Don't leave any in there, because this is your representative sample, don't forget. You have to try and get everything as good as you possibly can. Now take this, spread it all out as evenly as you possibly can, because what you're trying to do is you're trying to expose all this sand to the heat evenly, so that it'll evaporate the moisture at the same rate everywhere. Okay? Yeah. Lost a little bit of it. It's not, that would molecularly not be that much of a, it might not even be measurable, but the closer you get to the true state of this material, the closer you'll get to your the actually what you need to add when it comes to the moisture in your sand. Now I would have liked to have spread that out a little thinner, but at the temperature I'm going to have it at, an hour, yeah, that ought to have everything nice and dried out. Okay, so I think I'll go ahead and get the weight. I mean the little food scale, and bring it in here. And because I mean I don't really want to carry that through the house and possibly have that sand go all over the place. I think my darling wife of 43 years would be a little ticked off at me for spreading sand inside the house. So I'll be back as soon as I get this in the oven and it's an hour. Then I'll restart this video and we'll progress from there. Okay, now bringing you up to snuff, bringing you up to time. I went and found a pan that's a little bit bigger so I could spread it out a little bit thinner. I let it sit in there just to make sure it was dry, an hour and a half. It probably would have been dry at an hour, but I just wanted not to waste time and slow down the time for you guys. Okay, it took another half an hour for it to dry out, cool down from the 220 degrees that I had it in there. Okay, but it's absolutely dry. Okay, so what we need to do now is we need to weigh that. Okay, put you back on there, let you set. That's 0. And let's see if there's an easier way to grab this. Yeah, I think there's going to be an easier way. I don't want sand all over the place, otherwise I get beat up by the wife. See if there's something. Well, heck, I'll just use a gosh darn measuring cup of some sort. Come on, you doggone thing. Don't want it to turn off on me. Sure does have a okay. And the only reason why I don't just pour it directly into it is because I'm trying to keep a mess from being made in here. Once I get to the point where I can direct all of this with little chance of it getting all over, then I'll just pour it in it. Let's see if I can start adding that to it. Oops, making a mess anyway. Not the best job I could have done. Try to get the most, all of the sand that you can in there, because you'll be throwing the actual readings off if you don't. Alright, that's pretty good. Oh well, it isn't as dirty as Petrobond sand. Isn't that right, Randy, Bill Brook, all you guys? All right, so our reading now is 3 pounds 11 ounces. Okay. 3 pounds 11 3/8. Okay. On 3 divided by 8 equals plus 11 equals divided by 16 equals. Okay. So what we have now is 3 pounds 0.71. 3 pounds 0.71. Okay, so how am I going to figure out how much water was in there and that I've driven off? Very easy. This is your base number. This is the number afterwards. Okay. Let's just make sure I keep that straight. Okay, base number. This is fractions. Piece of cake. Okay, 3.71. Clear. Okay, 3.71, right? Divided by 3.77 equals 98. 98. This sand is 98% the weight of that sample. Okay, 98. Yeah, that's even rounding it. 98. Okay, that's a big answer that you needed to progress further. So we know that this is a representative, a good representative of the sand that I was testing, right? The amount of water and amount of dry sand, well, the dry sand / bentonite combination is going to be the same here as it is out there in the bucket. The reason why it is because I mixed it well so that it was the same through and through. Okay, now we know that sand, or rather the 42.5 pounds of sand, clay, water, that 98% of that, boom, is dry, the sand and clay. So let's clear that. Take 42.5 times 98% equals 41.65. What was that? 41.65. Okay, that's 98% of that. All right, so that 98% is 100% when it comes to this. All right, so this is now converted to 100% in our heads. 41.65. Okay, we know that we have to add 5% water to that 41.65. Okay, so that would be plus 5%. And that has to be 43.73. That's what it should be, but it's not. It's this. So 43.73, well, and on the rest, minus the actual, what we actual weight, minus 42.5 equals, we are 1 pound and 23, well, 1¼ pounds off. So let's make sure. We knew that this 98% of this is that. All right, now we needed to know, we have this, we need to know exactly how much to add water to that. Yeah, I think I had a feeling that I'm kind of missing out on something, but I think I'm still in good. So 41.65 plus 5% is 43.73. Good, that's what it should be if it was proper amount of sand, clay, and water, but it's not. 42.5 is what we have. Okay, minus 42.5 equals 1.235. So if you have one, two, what, three. Okay, if you had, this is dry, you add that, you're going to have the right mixture of everything. Okay? But we're not dry. I mean, out there it's not dry. So you got to figure out exactly what the percentage is of the water Well, how much is left in there? Okay. So we know that 98%. Okay. Yeah. Okay, this is this total weight, but that's not the right weight because that's not what we have. So we need to figure out how much we actually got out there. So this is where we come back to here. Okay. You need to figure out exactly how much percentage of water is in here. Okay. So 377, 98, 2%, 3.77 times 2% is 0.07. Let's say 0.08. Okay. Times 16 equals 1 pound, 0.2. Okay, while I'm struggling with math that I don't always use, I'm going to put you on pause so that I can make sure that I'm doing it the right way. I'll be right back. Okay, I'm glad I stopped myself because as usual I was trying to make things more complicated than they actually needed to be. Okay, we found out that the stuff out there that I have in that bucket is 42.5 pounds, and that is the sand and clay and water all together. Okay, now if you know that that's 90, what was it, 98%, you take 98% times that and you have where was it? I thought I wrote it down. Let's try that again. Oh, this is the number. Anyway, all right, this is the number. 98% of this is 4165. Okay, you take 4165 away from this, and you have the rest is water. So it's 0.85 water. Okay, that's the combination, right? Well, you're supposed to have 1 pound and a quarter almost of water for that mass of sand. We only have 0.85. In order to bring it up the way it should be, you need to add 0.4 pounds or 6 ounces of water to that and mix it up good, and then you'll be, you saw how out there I would grip it and it would conform to my fist, the inside of my grip, and it would almost be good enough for me to break it and have sharp edges all around and nothing else would collapse. It was almost that good. So really, and these are not fluid ounces, by the way. All right, don't get mixed up with fluid ounces and regular pounds and ounces. This is supposed to be almost a half a pound. Okay, so if it was actually a half a pound, it'd be 8 ounces. So it's almost half a pound of water, right? That's how you do it. All right, that sand out there, 42.5 pounds of sand and clay mixed with 1.3 pounds of water. That's your appropriate mixture. Okay, and that would come together as being what we weighed out there. I am going to double check that I ain't screwing up again. I was not totally off. What I had forgotten is that I had remembered that the scale out there said like almost 45, but I had forgotten that I had to take a pound and a half off because of the weight of the bucket. All right. Okay, so let's summarize. You weigh your sample, okay, which was almost 43.73 when you take the weight of the bucket off of that. You take a sample, or what did I say before? This is your sand. Okay, you weigh it, which is approximately that amount. Okay, you take your sample. Now you know this sample is going to be a representative sample because you mix that sand up really well. You take that representative sample and you weigh it. Okay, this sample came out to be 3.77 pounds. We dried it at, you can dry it at 220 to 230. Okay, don't forget that, write it down. You don't have to have it up to 500 degrees. You don't have to have it, and you certainly can't have it below 212 because you won't really drive off much of the water. So 220 to 230 degrees, right? Once it dried, once it's cool enough for me to be able to pour it into the basin, or the catch basin here, it came out to be 371. Okay, so we were 0.08 different, or rather 0.06 different. Okay, which meant that the sample that we brought in was 98% dry sand and clay, right? Once you found that out, you find your original weight. You know that that's going to be 98%. You find out, and that's not going to change. Then you take that and you find that you've got 42.5 pounds of sand and clay inside that bucket, ignoring the water at the time. Using that number, this is 100%, that's going to be 100%. You take that number times 5%, and that's going to be, you have to put in, if that's absolutely dry, which it isn't, right now. If it was absolutely dry, you would put in 1.25 pounds of water to bring it up to the state it's supposed to be. All right, but we didn't have dry sand out there. We had some left over, so we did the math, and we found out that the sand, 98% of it is this much. Take this away from that, and you had 0.85. You had under a pound, just under a pound of water. Okay, well, this, what you actually have compared to what you should have, you take this away from this, and that means you have to add 6 ounces of water. Okay, that's probably the easiest way to, unless you've got one of these, a food electronic scale, and you can just put in the water into that until you, yeah, it does do ounces. Let me double check. I think you can also go to grams. Yeah, it does ounces. You have pounds and ounces here. So you pour water into there until you get 6 ounces. Take that over to your mixer, and whether you want to mix it in through a sprayer or some other way, when you add that, you're going to be back up to your regular molding capabilities, and you can trust your sand to be a good general purpose sand. Now, that is what I left out. Almost anybody else can have a better grasp of math than I, but I didn't find this very hard. If you found it hard, it's probably because of the way I taught. So just go over it again and again. Substitute your own numbers, okay? And you'll find that this isn't that bad. You know, it's not that hard. If you failed in math, you might have a problem. Have somebody else do the math for you. Okay? Luckily, on all the ships we were on, we didn't have this type of sand, so we didn't have to do hardly any math on board. It was just a matter, you know, the math you might have needed to use to put the appropriate amount of metal inside the crucible and have no leftovers, you know, nothing to put in an ingot mold. That math, we went away from that too, because all we did is just put enough in the crucible. We knew it would pour everything, and then anything that's left over, we put in an ingot mold, and that's what we do all the time. Okay, piece of cake. So in the Navy, on board ships, math was useful, but not necessary. Okay, you were more inclined to have to work on having a good, strong back. Even the ladies, yes, even the ladies inside there needed to have a good, strong back, provided that they didn't talk their way out of doing regular molding work and just beg their way into just being the supply PO or some such thing in the foundry. I don't know anybody who did that, because everybody that I knew that was a LPO or a chief, a chief in charge, would have just through honorable usage of the persons would make them all be good molders by being able to do this. I mean, the ladies doing the same thing the men. Okay, it would be absolutely to me inconceivable that we would go back 20 years, well, even 40 years now, you know, judging by the time I've been out of the Navy, and just let the women do the easy stuff in the shop while the men have to do all the hard stuff. That's not what our ladies worked for, you know, in the women's lib movement. That's not what they worked for. Just so that, you know, people could connive their way out of hard work just because they were a certain sex. You know, I never bought that. And I probably lost one or two people out of the foundry because of my attitude. But I was looking at everybody doing the same thing and not have all the men pissed because I was letting the females do easy junk and yet still making rate. And by that, I mean, you may not... What happened to my light? The women... Well, that is on. This is not on. You know, it wasn't right. It wasn't right. And I got that message full, loud and clear. And I didn't believe in it in any way. So, I mean, everybody I know did their job, worked hard, and at the end of the day was able to either go back to their barracks, go into their berthing area, or go to their homes with a certain amount of respect for themselves, self-reliance. Okay? So, this might have been confusing. Just go over it a couple of times until you get it down pat, and then you should be able to handle it pretty easy. If I can do it, you guys and gals, any of you guys and gals can do it. All right? That's how low on the totem pole I am when it comes to math. So, for everybody out there, I'm sorry that it took so long for me to realize that I hadn't done this. And sorry it took me so long to get this up and going. But I will see you in the next lecture. And to all of you who knows what this means, hey, Liberty Call.